So in the chat, we had a number of different sort of topics suggested. So for those of you who are absolute experts at R, GitHub, etc., you may want to just chill out and take an hour off. But for those of you who maybe are a bit newer to R, a bit newer to version control with GitHub and tests and things like that, it might be useful for you to kind of watch and maybe hopefully pick some things up. So if I share my screen, what I've done is put together a very short presentation, and we'll go straight into the code. So I've definitely calling this last minute live coding. And it's always tricky when presenting live, because when you're working alone, you're quite happy, and then when everyone's watching, obviously everything falls apart. So what should we cover? So in the chat, there are a few different things mentioned. So there's some live code topics, so custom functions, documentation, unit tests. Unit tests were mentioned quite a lot in the last couple of, or in the first two presentations today, and good documentation. Also stopping code becoming like spaghetti and being really hard for new kind of people that are taking on a project or adapting a model, being able to do that. So we can talk a little bit about that. There are a couple of requests around survival analysis and adding sort of event costs and rewards into models. They're kind of a bit more topic specific, so might avoid those and stick more to the more generic skills. And then there were also requests around Shiny and R Markdown. But the one that got the most thumbs up, I think, was version control and sort of interacting with GitHub in R Studio and working together as a team. And so that's, I think, what we'll focus on the most. So in particular, this one here, and then we'll use some of these live code topics at the top as kind of examples of doing something live, but also interacting with GitHub, getting GitHub in R Studio to keep track of versioning while we're working. So first of all, version control is really, really hard. You can see here there's a lot of memes online, and there's a lot of people that have been burned really bad with version control. But not doing it is much harder. So not doing it well causes all kinds of hassle and problems. And there's a number of different benefits. So as well as working together as a team internally, there's benefits for external reviewers being able to access different things. So this is from a presentation we gave to NICE, where we were looking at what are the benefits of version control using script-based programming languages. And here we've got the example where we have a statistician, a modeler, maybe a whole team who have access to source code and open data, but also some sensitive data, and then having reviewers who are able to very quickly get a hold of open source code and data on GitHub, and then rerun models and review things rapidly is very valuable. Also being able to make code available open on GitHub means that some reviewers who may not need access to the sensitive data can still provide insight and information about the choice of packages used, the methods applied. Even without necessarily seeing the data, they can still provide some insight. And then some other people may want to just be able to see a GUI like Shiny. So they might not need the code, they might not care about the code or the data. They just want to be able to treat the model as a black box and play around with the user interface. But a lot of what's going to allow us to collaborate and work together as teams is going to be GitHub. So one of the first questions was around reviewing existing packages, so packages that other people have created, and understanding whether they're safe to use. And so I thought maybe starting with that was good, and then I'll jump into building up sort of collaboration with GitHub and editing code live. So just to build in. So we've got 4 commonly used packages here. So the use this package is a package in R that's often used to help build your own custom package. Plumber is a package that's used for creating APIs. R Markdown and Shiny you're probably more familiar with. So R Markdown's used for generating semi-automated reports. So reports where you have either code chunks or outputs from the code embedded into a written report. And then Shiny, we've talked about quite a lot. It's used for building user interfaces which can be deployed online and used to run, in our case, run your model for different parameter selections. So if just looking very quickly, so say, should we be using our Markdown package as an example before we go into some more health economic examples, or the Shiny package? We could go to GitHub before we download this, and we could look for, I don't think I've ever actually looked for our Markdown, but we could look for Shiny, for example, and try and find that. So I'm not going to search in my own one, I'm just going to search for Shiny. And we can see here that we've got all of the source code for the Shiny package. So rather than having the source code kind of hidden away somewhere, completely unobtainable, if we want to, we can go and see exactly what's happening with the Shiny package at this point in time. We can see who's contributed to this package. So here we've got a list of contributors, 84 of them. We can see what issues have been identified with the package. So here we can see things that people have flagged, and many of them will then be addressed either by the team that are building and maintaining Shiny, or by other people who just want to kind of collaborate on an open source project, and they would often do that in the form of pull requests. And so pull requests are essentially requests that are being made by somebody who's taking a copy of the code base to their own machine, made changes to it in some small way, and then now they're requesting to pull to essentially merge those changes in to the code base that exists online. And so here you'll see that there's kind of quite an extensive list of requests that are being made for people who are suggesting new functionality, or improving, fixing some bug, or whatever it is. And you can see here that these are by a large number of different people. So there's a large number of people collaborating on this. And so when reviewing a package, it's often quite useful to think, so how can I be confident that this package is going to do what it says it's doing? So we can see here that the release here is Shiny 1.8.1. If this was the first release, so like 0.0.0.1, then maybe you'd be slightly less confident. Something that's just literally just been released that week and no one's really used it yet, you might be a little bit less confident on. We can also see how many people have created a fork, so how many people have kind of created essentially a copy of this software. So here we've got 1.9 thousand, so that's a lot of people adapting and reviewing this code, which is always a good sign. There's a large number of contributors, and you can kind of look into who the specific people are. So here, that those of you that are kind of familiar with Shiny will know who Winston Chang is. And so there's a certain amount of credibility that is gleaned just from the individuals involved. So if you have several professors at well-known universities, that's always a good sign, rather than say one PhD student. And we can also look at obviously the issues that have been raised. And so one of the things that that people ask is, so is a large number of issues a good thing or a bad thing? And I'd say in general, if we've got a large number of issues and pull requests, and we're quite far into the releases, so we're on quite an established version, that's probably a good sign. If there are no issues, no pull requests, and you're on version 1, then it's obviously quite a new development package that maybe hasn't had much engagement, and so it's kind of hard to gain confidence about it. But there's definitely a wider discussion to be had about how, as a community, we validate some of these packages. So just to maybe put Nathan and John Luca on the spot, we can look at the Serve HE one, and it's incredible that it's completely open source. So we've got all these all this stuff here. So we've got here Serve HE, we've got version 2.01, so obviously much more established than most of the packages out there. We've got multiple people who've been involved with it. So we've got 6 people, and many of whom on the call, all with kind of doctorates and a kind of a reputation to lose if things go horrifically wrong. And we can see that here. So we've got 10 open issues, 24 closed. So it's got a lot of engagement, and you can see that we've got people from different institutions here all collaborating together, many of whom you'll recognize the names from. So another good example there. So thinking now about how we can collaborate, and I promised everyone a live demo, so now I have to deliver. Let's say we want to start our own project. So if I go to GitHub, I'm going to start my own project, and I'm going to have a look at our organization's repository and create a new one. And so I'm going to start a project, and so my first step will be to create a new repository. So a repository in GitHub is essentially a way of taking a project, essentially a project folder for the project that's going to contain all of our code, so that we can collaborate with others. So if you can think of it almost a little bit like a Google Docs folder that we're going to share, so that other people can interact with it as well. So here I'm going to call this R for HE for HTA 24 example. So I know to delete it later, and then I'm going to say example for 2024. So I give it a short description of what this repository relates to, and here I'm going to make it public, so that hopefully you can all see it. And I'm going to add a README file. So a README file provides a longer description on the project, so what the project's about, and you can provide quite extensive documentation about how to kind of engage with the project, how others can sort of install the necessary packages if it is a package, how they can, for example, run the model if it is a model, what dependencies it has. So it might, there might be some data stored somewhere else that someone has to go and obtain before they can run it. But also generally provide a structure for and a description of how all the code and data is structured. Then you get asked whether you want to add a gitignore file. So here I'm going to add the gitignore file for the default gitignore file for R. We can see that when it creates it. And here I'm going to make this MIT. So this is a license for others' use, essentially, to let others know what they can and can't do with the code by law. And once we're happy with that and you have everything there, we can click Create Repository. Now, if you've been doing this for a while and creating a lot of these, you can create a template. So here we have a number of different templates for different types of project. So it might be that you have a template for a project that relates to Shiny. So you might have a folder where you'd put, all the icons and stuff that generally go in your Shiny app. Or if you have a modeling template, it might be that you have a certain structure that your organization generally uses for a model. And so then you can create a template that essentially, when this repository initializes, the folder structure matches that template. But here we'll just create an empty one, just an example. So if I create this repository, we can then see it. It'll take a few seconds, and then here we go. So now we essentially have this project directory that's up online called a GitHub repository. And you can see that I've got what's called an initial commit here to add these three files. So I've got a gitignore file, a license, and a README. And so you might want to edit the README here, because this isn't particularly informative. So you might want to edit this file and say what you intend to do. So quite often we'll have, we'll have either some information here about an academic paper that the GitHub repository relates to, just to provide some context. And here they might have, say, the abstract for the paper, just so that people know, this repository corresponds to this paper, and this is what the paper is doing. And you might have information on, so this is, in this example, this repository is a package, so we have information on how do you install that thing, and then how do you use it, like what do you actually do with it. And then quite often you'll have a structure to the information in the repository. So here this describes what each of these folders contains, and these are the folders here, so that when you kind of log on to this, you can see, okay, so the R folder contains the functions, that this contains this contains this. Otherwise, people that are kind of new to this might be a bit lost. So going back here, we might say we are going to create in our folder, a test, and then collaborate. Of course, in real life, you're going to write much more extensive description than that. And so then here we go. So it's updated now to say what we're going to have in here. And yeah, you'd want much more extensive documentation there. So now I've got this this GitHub repository, which exists online on GitHub, but not on my machine. And so this currently exists within our organization, and it's public. So if I share the link in the chat, you should all now be able to go to this location and see this exact repository as it is. And this is public, which means any of you can go and have a look at it. But you can't make edits to this to the code base. So you can see it. You can do what's called forking it, which means taking essentially a copy of this over onto your GitHub account, and then you can make edits and submit what's called a pull request to merge those edits into this version. But you cannot directly change these files without my permission as the owner of this repository. But what I can do is grant people permission to do that. So here, for example, I can go to collaborators and teams. I can let's do that. I can log in and then make sure I'm happy with who has access. So here I'm going to add someone. Let's find Well. So let's add Well, and I'm going to give him write permission. So there's a number of different types of permission. So I think by default for a public repository, I think you will essentially have read access, so you can see everything, but you can't make any changes to the code base. But I'm going to allow Whale to make changes to the code base. So if I give him access to this repository, so the main ones I use tend to be either give somebody read access, write access, or admin access. Those are kind of the main three I tend to use. Admin access also enables people to delete the repository, manage others' access and things like that. So they tend to be sort of three main roles: read, write, or admin. And then the other two are slight variations on that. So I've now added Well, so he could make edits to the code base if he so likes. Okay, so now we've done that. We can also look at some of the other functionality briefly. So you can manage projects here with a Kanban board. So you can essentially create a new project here. Let's just show this very quickly, and then you're essentially going to get a Kanban board style visual, so that you can see exactly who's working on what, which issues have been addressed, which issues are ongoing, and which issues are done. And you can link that to the specific kind of issues you're addressing at the time, and you can have one of these for each project you're working on, which is very useful. So let's go back to the repository. Okay, so now you want to get started linking this up with RStudio. So now once I'm ready, and this is kind of a sort of documented, I've given access to people who need access, I can create a copy of the URL for this this code, and then I can go to RStudio. And so here I'm going to go to the top right corner where we have this project summary, and I click on new project, and it will take a few seconds to load up because I'm sharing a screen. And then I'm going to go to version control, git, and paste in this this URL. Now I need to specify where on my machine do I want to put this. So for the purposes of this demo, so I'm going to delete it straight after, I'm just going to put this on the desktop. But generally it would be in some project folder for the client project. And if I click create project, I now have essentially a clone, a copy of the materials that were on that GitHub repository now on my own personal machine. And so what's happened is it's copied down those files. You notice when we're on GitHub, so if I go back here, I have three files. I have a .gitignore, a license file, and a README. If I go to my machine now, I have a gitignore, a license file, a README, and this new file, which is an R project file, which has been created because I've initiated the project up here. So when I created the new project, the first thing it does is create an R project file. But this exists on my machine and not on the remote repository, so not on GitHub. And so now if I want to do what's called push this file to that remote machine, to that remote repository, I can do that. Once you've got GitHub set up on your machine, you'll see in the top right-hand quadrant of RStudio, you have a Git tab. So now I can do what's called commit and push to send this file up to GitHub. So our project file. So it's good practice to include a message. So every change to the code base that we make is going to have a message. And so it's good practice to say you make a small change to a model, a very small adaptation. You'd write a short message to say, I've adapted the model in this way, and then everything is fully documented. So if I commit this, I can now push up. And so now what it's saying here is essentially you've just pushed the change that you've made on your local machine up to GitHub. So now when I go to the version on GitHub and refresh, we'll now see this this new file here, the R project file. So that's great, but there's been no code so far. This is all just set up on RStudio. So let's create an example. Let's grab an example file and move it over. So let's take the sicker model example. So if I go to where my desktop is it? So now I have this folder, which is can't remember where I put it. Yeah, R for HTA 24 example. If I paste that in, we now have this file, which is a state transition model that we use for teaching from the Darth Sixica model. And this is a big long file, and we're going to have a load of parameters. We've got discounting. We created a transition matrix. We're going to check that transition matrix, all the rows sum to 1. We're going to create a Markov trace. We're going to run our model, and then we're going to produce a quick, very dirty plot to show where the proportion of the cohort are any given time. And then we're going to estimate costs and qualies and get a set of results and calculate an ISA. And that's all this file does. So it's 167 lines of code that runs a 4-state state transition model and returns an ISA. So that's fine, great. So we've got essentially our model here, and so I can go ahead and commit this and put this on there. So this is like a first pass. Let's say this is my first attempt as a kind of junior member of the team to build the model. So let's commit that. And so then we've got our model. I'm going to push, and I'm fine. So this is essentially the same model that we teach on our course for Shiny. So it's already this is already in the public domain. So not sort of showing anything new, but hopefully it's useful for people to see. So if I go here, we'll now see that we have this new file here, stm_01. And so what I'll do is ask Whale to maybe take a quick look at that file and make a suggestion, so create an issue. And one issue I might suggest that he makes is that currently when I build the transition probability matrix, we have a matrix here, and the only test I perform is that all the rows sum to 1, which here I've just added in a quick check that the rows sum to 1, but I might want to do some more extensive testing. So Whale, as my boss, as my reviewer, might say, can we add in some more checks and tests here? What if the values are lower than 0 or higher than 1, but the row still sums to 1? Or what if we've got something weird in here? Let's just check that. That might be the sort of thing that somebody might say. And so then hopefully at some point, if Whale's not gone for a cup of tea or got too bored at my talking, he'll create an issue. Okay, so Howard's corrected my Oxford grammar, which is brilliant. Very good. So for example, that's a great point. So Howard's now created an issue. And so what I might want to do is now go back to RStudio and correct this. So Howard said, let's change the README. So I'm going to copy exactly what Howard's asked for. I'm going to come over here and I'm going to see, okay, so I've not written this correctly. So one of the things I can do, because we want to make sure that we are not making potentially breaking changes to our main version of our code. We want to make sure that the trunk of our code, our code base remains nice and safe. So what I'm going to do is create what's called a branch. So I'm going to create a copy on my machine of this main branch in a new branch. Then I'm going to make the change, and then I'm going to submit a pull request in for somebody to review to make sure it complies with what they're looking to change. Because what we don't want is to all be working on the same thing, like you would do in a Google Doc, which allows everyone to work live. That's great when you're kind of working collaboratively on text. It's awful for code because obviously one person's change affects other people's code as well. So here I'm going to say, so I tend to call my branches rs underscore and then whatever it's for. So I'm going to call it Grammar Nazi for no particular reason. And so now I've got a new branch, and I'm going to copy in Howard's suggestion, and save that. And you'll notice now that we've now got a little M symbol here next to the README. So that's to let me know that I've modified this file, this README file. And I'm gonna stage that, commit it, and say error in grammar, and commit that change, close, and push. And so now this is going to send this up to a new branch of the GitHub repository. So when I come here, we can now see that we've got the main branch, which remains unchanged. So this sentence here reads exactly as it was before. But if I go to the new branch I created, this now reads correctly. Okay, but now as long as the reviewer is happy, we want to get this change into the main branch of the repository. So we might, and the reason why this is useful is we may, for example, build the first pass of a model, but then we may have a statistician working on one part of the model. We may have a health economist working on another. We may have somebody documenting things up. And so 4 or 5 of us can be working simultaneously on the same model and then submit in pull requests to the main branch. And so then the aim is that by the end of the project, we have a nice, tidy, finished main branch, but people can be simultaneously working on their own tasks. So it makes things much more efficient. So we can now compare and submit a pull request for the changes I've made, and generally write a longer description here. So you say, I need to write Weller. There we go. Okay, so and you can see exactly the change you made. So you can see the version of the code in the main branch and the version of code in our our new branch that we've created, and what we're going to overwrite that with. So old is in red, new is in green, and so we can see the exact thing that we changed, just a comma here. And so I can create this pull request and assign a reviewer. So here I'm going to assign it to Will to review, because he's got write access. And so one of the first things it's going to do is it's going to say, are there any changes that are conflicted? So this can occur if 2 people essentially create branches and then make changes to the same line of code, then you can get a conflict. So this is checking, are there any conflicts with the other branch? And then once we're happy, so Whale here agrees with the changes, and so we can see his review. He's very quickly said, I agree. And then I can merge those changes in. So I'm going to go ahead and merge those changes, and then I can delete the branch. And so now our main version of the code contains this this corrected sentence. So we could have, when we merged that change, we could have included a little reference, close hashtag issue1, and it would have automated the close, so it just automatically removed this or closed this issue. But because I was kind of talking through, I forgot to do that, and so we can manually just click close issue. So everyone's happy, issue closed. In the meantime, while I've been killing some time for Whale to make some suggestions based on the code, the model I submitted, Whale suggested some more checks to add in. So he said, can we suggest these probabilities are above 0? And GitHub's really nice because you can literally reference specific lines of code, and we can see those lines here. So I can click here and get taken exactly to the line of code that Wales referenced. So he's referenced this line 81, which is really useful when you've got an extensive code base and you're trying to talk about the code base rather than emailing saying file, model A line 153, please could you do this? You can literally click on the line and say reference the new issue, and then reference that as Wales just done. So it makes it much easier for us to discuss and talk together about the project. So with that in mind, I would then create a new branch, and I have to be careful to go back to the main branch and create a new branch off of main. Let's make sure first of all that I pull before I do everything. Create a new branch, and here I'm going to call this RS more checks, just as a quick thing to be able to create a branch and very quickly see that this is the branch that I'm working on. So RS, so Whale might call it his, and then kind of a very brief thing so that we know what this branch relates to. So now I'm working on a new branch, so I can make any changes I want here. If I don't like my changes, I can just throw them away and go back to main, which is really reassuring. But now I'm going to quickly run this code and then make some changes when I get to line 81. So here I've got my initial checks, but actually what I'm going to do is I'm going to use the package that I talked about on Friday to make a quick check of this matrix. So here's what the transition probability matrix look like, but rather than write a ton of tests here, I'm just going to use the ones that I've already written and included in a package. And you can see that it's done it and it's not flagged any errors. I can get it to confirm that everything's okay rather than just be silent. So it's saying passed all checks. And just to make sure, just to show you that it would flag an error if there's a problem, let's randomly change one of the things. So let's change the probability for everybody in the S2 state to be minus 0.1. So now if we had this transition probability matrix, you'd probably be thinking, this isn't looking so good. So hopefully, like fingers crossed doing this live, here we go. So it's saying we got a transition matrix with values below 0 or above 1, and also the rows now don't sum to 1. So there's two errors here. One is that we shouldn't have negative values in here, and the other error is that when we sum all the rows, they don't sum to 1. And that's important that we got two separate errors because we could have a negative and then a positive that cancel each other out so that the whole thing sums to 1 still, and the other check wouldn't have flagged it. And so now I've got this this new check in there. I'll get rid of that a little bit. I don't need the old one. And so I can add that in. And so now I've got a new line of code. So when I come over here and commit, I'll be able to see what have I added versus what have I removed. So I've removed my old check here, row sums, and I've added this new check with this external package just to check that the transition probability matrix complies. And I'm going to say added in assert checker or prob that check, commit that, push. And then if I go back to the repository, this one, and go look at this, you can now see that it's flagged to say, this branch has changed only 8 seconds ago, because it's very likely if you just push something that you're going to want to merge. That's why it's flagged. It's kind of saying, do you want to merge this basically? And so I can click here and it will take me to the merge file. Just going back to Wales issue here, this is issue number 2. So if I remember that, this is issue number 2. Come back here and say, okay, so I want to merge this. I have added in assert HTA, more info can be found here. I can add links in. I can add pictures. I can add a video. Like I can have basically whatever I want to justify why I've made this change. And then I can say here, I'm going to say closes number 2. And what that means is that when I create this pull request, I'm going to choose Whale to review it. So I'm going to create the pull request. And when this pull request is accepted and we merge into the main branch, it's going to automatically close that issue. And so what our kind of workflow is as a group in Dark Peak Analytics is essentially to create a load of issues, a load of things that we need to do on a project. And then as we solve each one, we close it. So we kind of gradually see over time, oh yeah, okay, this is what we need to do, solved. This is what we need to do, solved. And then gradually over time, we kind of work through them. And then when we struggle, we have a big, long discussion down here. And so it might be that it might be that I could have mostly solved the problem, but I needed a bit of guidance. And so then Whale could have given me some guidance back and forward on this discussion until we'd resolved it. And then once we've resolved it, we can click resolve, brilliant, and then merge, confirm merge, and then everything's done. So yeah, sorry, I'm really winging it to fill these 2 sessions, but hopefully that was useful. If there are any questions, then we could do a couple of minutes of questions and then stop. Sorry, I've not been looking at the chat. But I'm also chairing this session, I realize. Okay. Does anybody have any questions that wants to like speak? So it's not just me speaking for 40 minutes. Hazel, yeah.
Hello. Just a really simple question. But you very quickly deleted your branch. And I just wondered, would you always do that once it's been okayed, or would you ever have a reason for keeping them for like a record?
Yeah, you can keep them for a record, and you even if you've deleted them, you can restore them back.
Oh, right, okay.
So yeah, but the only reason I delete it is that otherwise you just end up with like a huge number of branches. Because if you imagine each one of these changes might be like a couple of hours of work, and if your project is a month long or
Yeah,
6 months long, you can end up with quite a lot of them. So I tend to by default delete them, and then if I need them, I restore them back in.
yeah. Okay,
Yeah.
that's useful. Thanks.
Cool. Thanks for the nice question.